Hello, and welcome to the FIB Young Members Group Rising Stars Podcast series, where we interview the most successful and prospective young engineers and researchers in the world. My name is Nikola Tošić, and I'll be moderating today's talk with Dr Andri Setiawan, definitely a rising star, both within the FIB and beyond. Andri is a postdoctoral researcher at the Politècnica University of Valencia, but has also been a researcher at EPFL in Lausanne. Andri completed his PhD at Imperial College London under the title Efficient Strategy for Modeling Punching Failure of Flat Slabs, and has dedicated himself, among other things, to punching and shear in concrete structures. Andri has worked on several research projects at eBeton at EPFL, collaborating with Professors Mutoni and Fernandez-Ruiz, among others. Andri has published numerous articles in journals and conferences and is the winner of several awards, among them the Adam Neville Prize for the Best National PhD in the field of concrete and cement in 2019. Andri also has experience as a design engineer, working on several commercial projects in the UK and Indonesia. Last but not least, he is the secretary of the International FIB Young Members Group and also very active within the FIB Young Members Group in Indonesia, hosting several workshops and webinars engaging young engineers and researchers. Thank you for joining us, and I hope you will enjoy the podcast. Hi, Andri. Thank you so much for joining us. This is our second podcast in the Rising Star series, and I'm really happy to have you on, because for me, you're kind of really an example of something that we need more of in research, in industry, a young, ambitious, successful researcher and engineer, but also someone who's, I think, giving back to the community with a lot of your involvement in the FIB Young Members Group, above all, both internationally and nationally. So I will have recorded and introduced you in an introduction. So here we can jump straight in. So we are now, let's say, we have come back from summer vacation. So tell us, what you are doing now and what are the latest activities that you're involved in that are now starting, let's say, from September.
Okay, thank you very much, Nikola, for having me in this podcast. So yes, I'm currently living in Indonesia. It's a bit different in Europe. Like we don't have summer vacation here, but we are a bit busy actually nowadays. And currently, I'm involved in several activities, I would say. The first one, I actually established also my own design office in Indonesia. We had
Congratulations.
Thank you very much. Yeah, we had some collaboration with, let's say, Japanese companies to promote their seismic dampers in Indonesia, because we know Indonesia is a seismically active regions, and we want to introduce this technology to society so that they are aware about the importance of having their buildings designed against earthquake and so on. So we are helping them to promote their technologies. And another activities that I'm involved right now is in research, as you might be aware of. I'm still doing research with my colleagues at EPFL, because last year we finished the test before I returned to Indonesia, but now we are still working on some papers that I will tell you in more detail later about the project. And also collaborating with my former university in Indonesia. We also have some ongoing research activities. And yeah, I will describe to you also later, I think, in more detail. Okay. Thanks for asking, Nikola.
Yeah. I also want and have things I want to go into detail, but now that you said a couple of things, I wanna pursue them. Just maybe for the uninitiated like me, you said I didn't know, like, is there summer vacation? No, but now that you mentioned like collaboration with Japan, I'm interested in Indonesia, let's say the construction industry or design philosophy. How would you describe it closer to maybe Japan or Australia and these British standards, or what is the situation?
Okay, generally, I would say that, let's say, the practice that we adopted here and the codes that we refer to is more similar to the American one, basically. So we design the concrete structures with our own national standards, but it is very similar to ACI, for example. And also for the steel structures, we adopted many similar provisions with the AEC. And even for the earthquake loads and everything, we adopted the ASCE 7, for example. And we have some influence from, let's say, European standard and also British standard, but only on some, let's say, small aspects in our design, especially for some aspects that are not fully covered, for example, in the American standard. So sometimes we refer on the European standard, but in general, we are more, let's say, closer to the American one in this case.
Okay, okay. No, interesting. Thank you. I just thought that for me it was an unknown, and it's interesting to know because all these countries are in the FIB, and let's say probably we collaborate more in research on similar topics, similar models. But then when you really go into practice, and the FIB is the bridge between research and practice, but it's a long bridge, I think, at times. So it's interesting to know what it is. So you mentioned also your let's say alma mater university from Indonesia. So can you introduce us a bit? For me, it's always an interesting question of how you chose or came to study civil engineering, came to do then later doctoral dissertation. Was it like linear directly after studies? Were there some break going into industry? Yeah, please, in general, just kind of the trajectory and motivations.
Yes, thank you, Nikola. Yeah, first of all, I think I would like to describe a bit about the university that I was studying in Indonesia. It was actually one of the oldest, let's say, universities in Indonesia. It was established in 1920. Previously, it was actually named in a Dutch language, actually, because we had a lot of influence from Dutch cultures. So I think we call it even like a hogeschool, like a technical school in Dutch. And we had a lot of, like professors coming from Delft, for example, and so on. And yeah, and I think it's, let's say, one of the best, let's say, engineering schools that people want to go in Indonesia. And we had a lot of notable alumni here who works either in Indonesia or also abroad. And at that time, I was actually not choosing civil engineer as my first option or first priority. It was a bit, unexpected. I was choosing chemical engineering at the time, just because I thought I really like doing chemistry and also physics in high schools, and I thought I'm good at them, so I tried to pursue a degree in chemical engineering. So I put civil engineering as my second option at the time, and at the end I got the decision to join the civil engineering. And yeah, it was initially a bit, let's say, unexpected for me, because I was not expecting to study this degree, but I received a lot of, let's say, motivation also from my parents, because both of them are civil engineers. Both of them are also lecturers in civil engineering.
Okay.
And they were the one, they were the people who were really happy when I got accepted to civil engineering, not to chemical engineering, because it's a bit like a legacy that they want me to carry on, basically. But until now, I never regret the decision to finally accept the decision to go to civil engineering degree. And yeah, just to let you know that the undergraduate degree in Indonesia is also similar to US system. So it's 4 years basically. And in the final years, we need to do a bit like a small research project, and we can choose our own topic to work on and so on. And then I did that, and I continue my master degree in the same university. At the time, I was quite fortunate because there was a new program basically which combines undergraduate and master degree in 5 years, because normally you need to spend 6 years to do it, 4 years undergraduate and plus 2 years master. And they created like a new program. They call it fast track program. Basically, they allow you to take some master courses during your final undergraduate years, basically. So I managed to finish the masters in 5 years. And just after finishing my master degree, actually, I have made my mind to continue to pursue my PhD. I got a lot of support from my supervisors and also from my parents. They told me that if you are sure that you want to pursue a career in research and you want to do more studies in your field, then do it. And then that's why I decided to pursue my PhD. And
sorry,
yeah,
I wanna jump in here
yeah,
just with some questions. So
yeah.
I can relate completely. I'm also from parents who are both civil engineers, and I find it
Okay.
is often kind of family, like you say, legacy and tradition to continue. But I'm also interested, for example, in Indonesia, because in different countries, let's say, the respectability of or renown of a civil engineer is kind of varying. There are societies where it's really like a respected profession. Here in Spain, I was surprised how much it is, for example. So here it is called ingeniero de caminos, canales y puertos, like an engineer of infrastructure, basically. And when somebody hears that you are this kind of ingeniero de caminos, it's really like a respected profession. So I'm also thinking within this choice of chemical civil engineering, like when you got the decision to go into civil engineering, what did you see your future like? I mean, what is the like professional outlook there?
Yes, I would say that civil engineer in Indonesia is also seen as a respected profession, basically. One of the reason, although it's probably not directly related to each other, but our first president actually was a civil engineer as well. And
Okay.
he built the country, like literally, like as a president and also as a civil engineer. And, like we are always very proud, to call ourselves as a civil engineer. And as I will tell you probably also a bit more later, that our country now is currently building a lot of new infrastructures. We are in the infrastructure boom that happens in the US or in the Europe in 1960s or 1970s. And now we are in that era. And I think it's really a privilege for us as a civil engineer who is, like who can contribute and also use this opportunity to contribute to the country, to build the country. And yeah, I think it's always a career that, everyone can respect and everyone wants to achieve as well, I think.
So the let's say undergraduate let's say final work, or let's say thesis, perhaps you said it's a kind of research work. So I understand that that's something that directed you towards research, no?
Mm-hmm. Yeah.
Okay. And then can you tell us a bit, because your PhD was not in Indonesia, no? Then
Yeah.
how did that develop? Because I think it's also a very competitive environment to get scholarships, to go to prestigious universities like you did for a PhD. So let's say for anybody also listening who is kind of contemplating this, what's your trajectory and maybe some advice that now in hindsight you know?
Yeah. Thank you very much, Nikola, for the question. Yeah, actually, like the project that I did in my undergrad was, let's say, my first exposure to research. And I would say it has a big impact to me, like it was a very nice experience to work on that kind of project. And especially in my master degree, the project that I was working on in my master thesis was actually also applied in a real project, because basically like I designed a building using a new technology, and at the same time, the results that I obtained from my study was applied in a real construction.
Okay,
So
awesome.
it makes me realize that, like doing a research doesn't mean that you are disconnected to what people are doing in practice. And that experience made me realize that probably if I study more, like doing more research, I can also, contribute more to the society. And at the time, I had several, let's say, options about the topic that I want to pursue in my PhD, and several, let's say, universities that I want to aim. And I was quite fortunate. First of all, at the time, I had some friends, some university friends who were studying in the UK before me. Basically, they did their masters in the UK. I communicated a lot with them. They told me about how let's say the environment that they are having there, about the quality of staff, quality of teaching and research was, let's say, very nice, very great. And then it was also one of my first motivation, like to pick a UK. And I also know that, like probably the language will be the easiest for us, because English we learn it from elementary school or even earlier. So I think language barrier would be one of my first consideration also. And then another thing was to find a scholarship. And yeah, our government at that time was establishing their first, let's say, I was not the first generation, but let's say one of the first 10 or 20 generation, basically the first 10 or first 20 generations who were, let's say, financed to go abroad to study and to pursue a higher degree. And they encourage us to pick, the best universities in the world. Let's say the best 50 or the best 100, the higher the rank, the better, like they need to have some, let's say, a quantity that they can, they can use as a benchmark.
Mm-hmm.
And at the time, I chose to pursue my degree at Imperial. And at the time, I had no idea exactly about what my research will be. I just know at the time that I want to do research in concrete. That's all. So the first, let's say, step that I did at the time was just looking for the professors who are an expert in concrete, doing a research in concrete. And that's why
an interesting question also, like at that time. Now of course I think or at least me, after the PhD you know to estimate who is a good researcher, so searching publications, citations, etc. But at that time, what was your criteria for searching a good researcher?
I didn't have, I would say. I mean, it was really, I don't know, like I was not exposed to, to research environment, even like reading a paper, probably just 5 to 10 papers that I read, to finish my master thesis and so on. So what I did at the time was just looking for some, let's say, some website. I look for some professor, their homepage, the profile about what kind of research they are doing. I haven't recognized, like about some impact factor or citation or anything. But yeah, at the time, I just chose my supervisor based on the research interest.
But it might even be a good thing, because I think what happens then is that, the response you get from the nice people who will take the time probably to respond to you, and that's maybe sometimes even a more important criteria for having a PhD supervisor than just based on citation metrics. You could find that the best guy, but collaboration with them can be tough. So maybe it's even a good thing that we don't know, so we just go with kind of open heart and open arms, and who receives us, right?
Yeah, I totally agree. Like I sometimes I joke with my friend, but like I told my friend that if you are looking for a supervisor, it's like looking for a girlfriend or for a wife. Like it's not just about the reputation, it's not just about the numbers, but it's more about how you can build your relationship and how you can be the best of you. Like to really nurture you, to really encourage you and motivate you. And it's something that you cannot just see from the citation or from the numbers. And I was quite fortunate actually to experience this positive environment and positive experience.
Definitely. Now also looking from the other side, being a PhD supervisor is really a huge responsibility. It's not just a professional, but you have people, well, like me, like you, who change their country of residence, move halfway across the world, and they really depend on you a lot, right? So tell us, you went from thinking about kind of chemical engineering to really pure hardcore structural engineering. So your research is, as I understand, structured on punching shear or flat slabs. So tell us a bit about, let's say, the PhD, the development that was there, and I think that led you also later to your postdoctoral research.
Yeah, sure. Thank you, Nikola. Yeah. At the beginning, my research topic was focusing more on the behavior of flat slab in seismic regions. And why I chose that topic, because in Indonesia, we don't have many flat slab buildings. And one of the reasons, because we know that the system does not perform quite well in earthquakes, And at the time, we decided, let's just focus on the behavior of flat slabs under seismic loading. And then that was my, let's say, my focus in my first year of PhD. And of course, like along the way, you read more papers, you met more people, more experts during the conference and so on. And in the second year, probably I realized that there are more, like potential research gap that are, let's say, relevant to a wider audience, that can be applied not only just in seismic region and so on. So we decided to not leaving the topic completely. We are still focusing on the flash labs, but we changed the topic a bit about the modeling of flash labs. Why we chose to work on the modeling? Because we know that punching, I will describe it in a bit more technical, but punching is a bit, like a complicated phenomenon. It has a three-dimensional nature. It involves, 3D behavior of material, of concrete, and so on. So when you want to model, let's say, punching shear in a computer simulation, typically you will use like solid elements because you want to have a 3D triaxial criterion. So you want to completely simulate the behavior. And the problem with the 3D solid is that it's not very, let's say, timely efficient. Like if you want to build a structure, like a whole structure, I don't think you can. So that's why usually you only cut like a small portion of the structure. You call it like a sub-assembly, and then you model it using 3D solids, and then you analyze it. But let's say if you have an assessment of a whole building, it will be very expensive computationally if you use solid elements. And we thought that probably we can propose another modeling strategy that is, let's say, more suitable for assessing the whole behavior of structures. And we decided that we can try to do something by modifying a 2D shell elements, because with 2D shells, you can really reduce, let's say, the degree of freedom in the structures that you analyze. You can simplify the model, and at the end, you can run the model faster. But of course, you need to do something with the 2D shells, because, the nature of 2D shell is that it only captures, flexural behavior of the slabs, but it cannot simulate punching. And that's why we decided to, to incorporate additional, let's say, like a spring or a joint elements with a failure criterion into a model with shells. The idea is to simulate the flexure with the shells and separately simulate, let's say, the punching using the joint elements or the spring. So we can combine, let's say, the advantages of the two and end up with an efficient yet an accurate model that, let's say, engineer can use even to simulate, a whole structure. That was the idea.
Okay, no, sounds really, let's say, complex and in-depth. So I can imagine starting that work might have felt overwhelming. So what was the, let's say, supervision like? Was it first entering into literature? You had to maybe increase your computer programming literacy or so on. How was the learning curve?
Yes, I cannot deny that the learning curve was quite steep, especially during the first year probably, because even for myself, like doing a literature review on papers was not something that I did for my, like in my daily activities. It's something new for me. And fortunately, in our university, in the first year, every PhD student we must meet our supervisor once in a week. We have a routine meeting once in a week to, report some progress. Even when we were just doing literature review, we still need to, report some of the progress, because I think it's also a crucial stage, to be able to identify, let's say, the main findings from studies, and also to identify the gaps that they don't have in their research and so on. So during the first year, mostly I did was literature review, probably during the first 3 months. And in the UK, you need to submit your very first, let's say, proposal after 3 months starting your PhD. Basically, that was, let's say, that is the first checkpoint. And then another 6 months, basically 9 months after you start your PhD, that will be your second checkpoint. It's called early stage assessment. You need to submit a proposal that is already more, let's say, refined, more detailed. And you also need to defend, you need to present and also defend the idea, to present it to your supervisor and also to the other examiners to make sure that your, let's say, your research idea is doable within the time frame, the 4 years time frame, and whether your research idea is really novel, because probably they know better whether someone has done it before or not, and to make sure that there will be a real contribution from this project. And during the first years, I think I did literature review and also learning to, let's say, use some numerical software to do modeling and so on, and getting to be more familiar with design codes. I think another interesting thing that I experienced was, let's say, the gap between the codes that I use in Indonesia with Eurocodes, like, because we never heard about Eurocodes before, or even, like FIB model code both are very new for me. And during the first few months, I also used some time to understand the philosophy of the code, because, without really knowing about the code, I think you lose some of the perspectives about how engineers typically do, to design punching shear, for example. So that's why I decided to spend some time, not just to use the code, but to understand the philosophy, behind the code, like the model code, what's the main difference between the assumption in Eurocode, in model code, in ACI, and so on. And, like to find some ideas about, what kind of improvement that we can also contribute from this research. I think that was the highlight of my first few months and first year of PhD.
No, your topic really is, let's say, the kind of core topic of structural engineering. I know for punching in Belgrade, we were giving some courses because in Serbia the Eurocode was also introduced relatively recently even. And then there were courses of, let's say, training practicing engineers, but now in Eurocode. So the course would be also general and so on, but the questions would always be about punching. And this is true when you go into even the background documents and stuff. The books, they give you an example of like, a central column, etc. But then people come for practice. Okay, I have a circular corner column with bending moment. There's no example, developing it really in detail and so on. So, on that note, that saying, let's say, learning curve, new country, new probably kind of work culture in general, in the sense that it's different working on a PhD. Of course, it's now clear from the results that you became really good at it, and you transmit a love and passion for the job. But for me, it's always a question. If it's even a question, what comes first? Do you like become good at what you love doing, or you start to love doing what you're good at? Because from my experience also, I think when you are kind of coming to a different place that's offering you perhaps opportunities, you are really then motivated to give it your all. And then for me, it's more even like you start loving something that you're good at or that you are benefiting from. But I'd like to hear your thoughts on that.
Yeah, for me, I would say it's a bit of a mix between the two, because when I started my PhD or choosing my undergrad in civil engineering, of course, I hear about, like how structures were built and so on, probably from my parents, like I heard about that many times when I was a kid. Probably that was, let's say, one of the first exposure to civil engineering. So there is a bit of, for sure, love about that subject. But as the time progresses, as I learn more about the subject, actually, I think I fell in love more about the subject, because I think not every subject is like civil engineering from my perspective, because it's really, I don't know, tangible. You can touch the thing, like it's not about some rocket science or something. You can really touch the building that you designed, that you built. And another, let's say, thing that I'm really proud of as a civil engineer is because you can directly contribute to society. Like, for example, when you build a school, it's not just about the building, right? Because if it's just a building, then it doesn't really matter. But it's also about how you accommodate students, like how you accommodate young kids to learn and use the school. And also, let's say, if you build a bridge, you literally like build a bridge, like not just connecting the two places, but also connecting two cultures or connecting two different regions with different barrier, And I think it's really the wonderful thing that you can achieve as a civil engineer. And for me, actually, like, I also fell in love with concrete structures for some reason. I don't know, like specifically about concrete, because, it's a bit of a mix of everything. I mean, you know about the concrete probably better than me, but it's a mix of everything. And it's like a heterogeneous material. It's difficult to understand, but somehow it works collectively, like the aggregate works with the cement and so on with the water. So there is a complex interaction, like I would call it like a society, like every part has different functions, but when they work collectively, it becomes very strong. And also the function when concrete meets reinforcement, reinforced concrete, there is a division of work, like the concrete carries the compression, the reinforcement carries the tension. It's very nice, to see how this kind of system works, and also the creativity when you talk about, let's say, post-tensioning or pre-stressing. It's let's say it's a wonderful invention, like you know that concrete weaks in tension, for example, and then you create something to overcome let's say the limitation that you had. So it's very nice, I think.
Yeah, I think what I like is that you, like you said, I think you cover like a lot of orders of magnitude of scales that you consider, right? From the whole bridge, mega structure, and so on. But you also have to go into the details of durability, chloride ingress in the concrete cover, and so on. So you're really like transversing this micro, meso, macro scale on a daily basis, probably, right? Maybe you are sometimes more directed to one thing or the other, but yeah, it offers you a whole range of topics. So tell us then a bit more, take us further, let's say finishing the PhD. I think you were already probably aware that you were doing a very good job at it. And since it seems and it's clear that you love the profession, you are continuing, or you decided then to continue with the research. How did that go? Your next engagement was in EPFL in Switzerland. I understand a bit more in line with the PhD, but tell us a bit this collaboration, if the FIB had any role in it, and how this transition went.
Yes. Okay. Thank you very much, Nikola. I think it's very nice and interesting question. Yeah. So when I finished my PhD, I mean, not finishing yet, but probably during my third year or entering my fourth year, I realized that, let's say, the majority of works that I did in my PhD was, let's say, purely numerical, from numerical perspective. And I really think that there is a bit something missing, by just understanding from the numerical perspective without really doing some like physical tests to really validate what you did in the simulation, and without really understanding and see how the cracks propagate and how the failure forms and so on. And first of all, I think FIB has a significant, let's say, contribution to it, because you know that when I finished my PhD with Robert Follum at Imperial College, then I moved to EPFL with Professor Oliver Muttoni, and I met Professor Muttoni first time during the FIB conference. In particular, in the FIB PhD symposium in Prague, I think in 2018.
Yes.
Yeah, I was presenting my research there in the same room with Professor Muttoni, and then he asked some questions about how I applied his theory into the numerical model and so on. And from that, let's say, small conversation, it develops, like we decided, me and Robert Follum, we decided to invite and ask Professor Muttoni as my examiner for my PhD defense examiner. And yeah, it was a very nice experience for me, because, like in my PhD research, I use his theory, I applied his theory in the numerical model, and having him as my examiner is like, like putting the cherry on top of the cake, like it completes everything. And after that, let's say, interaction in my PhD defense, I decided to try to contact him to find out whether there is a opportunity, to work further, to develop my research further in his lab. And at the time, I specifically asked him to work on some experimental tests, actually, because I told him that I did numerical modeling in my whole 4 years of PhD, and I really want to complete my skill sets and get new experience by doing some tests. And I know that EPFL has a very, let's say, sophisticated labs with state-of-the-art, cutting-edge technologies to do the measurement and everything. Basically, they have all the facilities. And yeah, I applied for it's called Swiss Government Excellence Scholarship. Basically, it's for a postdoc who wants to do a research in Switzerland. I discussed with Professor Mutoni and also Miguel Fernandez Ruiz about the topic that we want to work on. And yeah, we decided to work on a bit different. Let's say in my PhD, I was focusing mostly on, let's say, internal slab column connection, basically the column inside the building. And then for my postdoc, we decided let's try to do something more about the edge connection, the column and the perimeter, basically. And there are several reasons which, let's say, support the idea. First of all, because it's probably a bit simplistic, but if you see a building, actually, there are more edge connection than the internal one in the building. And somehow we did a lot of more research in the internal than the edge column, because it's a bit too complicated to test.
Yeah.
So we decided, okay, let's go for the edge connection. And then at the time, the next step was how to design the test setup, because the test is a bit harder to produce than the internal connection to test, basically. And then we developed in some months during my postdoc time. We decided to develop the setup. And I think the main, let's say, novelty that we did in that research in my postdoc was the use of a new measurement system. We employed, let's say, digital image correlation, to capture the cracks from outside of the slab, and also fiber optics. I think at that time it was, let's say, one of the first tests to employ fiber optics for punching. So we instrument all the reinforcement continuously for the tops and for the bottom bars, and also for the shear reinforcement continuously. So by doing that, we have a complete picture. We can see the crack from outside using the IC, and at the same time, you can correlate that cracks with what's happening inside from the fibers. And it reveals many, insights and new findings that we never thought before, like whether there's an activation of some bars that we don't consider before, and some, let's say, mechanism how the crack propagates, and how the crack propagates affect the development of strains inside. And it was a very nice experience. Like we built the slab, we instrument all the bars, we also design and build the test setup by ourselves. And at the time, I was very fortunate because I worked with 2 PhD students who are very supportive, very helpful, very smart, and they work really, really well. And I think we managed to find many interesting stuff that we are going to write soon and hopefully to publish soon.
Well, that sounds like a good progression. From the PhD, now supervising other PhD students, so kind of taking on new responsibilities. So how did you enjoy now that role, right, of the student being the teacher? Let's say you now supervising somebody, you trying to maybe replicate what was good in your supervision or give it your own touch. How do you see this job?
Yeah, I would say it's very nice, fruitful experience, but also a bit challenging, because sometimes the style that you think fits for you might not fit for your student, because they have different working style or working culture, or different background and so on. So I think one of the most important thing of doing that role, supervision role, is how you communicate with them, how to set your demands, but also to have a realistic expectation, but also to delegate, because you cannot do everything by your own. You cannot just trust yourself and not trusting everyone. You need to delegate and divide the work, give some trust to your PhD to work on that aspect independently, and also to try get some insights, get some ideas from their opinions, because sometimes, I don't know, but when you feel you are in the higher hierarchy, sometimes you are a bit, I don't need to hear this opinion. I know better than him or her. But I think it's really a not a good attitude, because even if we think we know better, but we still can get a lot of new information, by just listening to other people's ideas, your PhD ideas, and so on. I think that's very important, the communication skill, how to communicate your ideas, but also how to attentively listen to their opinions.
So true. I want to ask you now about your, let's say, future or newest engagement, which is, I think, that's something really exciting, and I was really, really happy to hear it because, first of all, you'll be coming here, much closer to Barcelona, actually to the Politècnica University of Valencia, where there is something that's really a rarity for civil engineering, and that's an ERC grant, right? So European Research Center grant led by Professor Jose Adam. And there are not many. So I was looking at a list of projects, and really few topics get this really prestigious grant. And I understand you're coming here to work on that project. That really, really sounds exciting. So please tell us a bit about the project and, let's say, you're now how you're looking forward to it.
Okay, thank you, Nikola. I feel so excited also to come to Spain, to another new country for me, new language and new culture to experience, and especially for this exciting project. The project is called Endure. It's, as you said, it's an ERC consolidator grant led by Professor Jose Adam of UPV. So basically, in this project, we are going to develop, let's say, a new technology to protect buildings against progressive collapse. Let's say traditionally, when you design against progressive collapse, you want to ensure that you have continuity. You want to ensure that when one of your critical column falls down, you want to be able, you want your structures to be able to redistribute the load to the other members without experiencing collapse, basically. And to do that, or to achieve that, you need to have like a tie system, like a proper tie with detailing, rebar with proper detailing, so that you can activate several alternate load paths. But what makes it interesting in this project is that the idea is a bit radical. In this project, we don't want to provide continuity, but we want to create a segmentation. It's basically like the opposite trend, like the opposite spectrum. So why is it like this? So basically, the idea is that in some scenarios, not in all scenarios, we are still working on, to identify which scenarios is like this. But let's say if you have not just one column, let's say you have 3 columns being fall down basically a collapse. Yeah, collapsing, like 3 columns collapsing. And in that extreme scenario with large initial disturbance, it might not be practical, to allow your building to redistribute the force, because probably there will be no surplus force, surplus ductility for that. In that case, probably it's a better solution to basically cut the part where the collapse occurs, so that the collapse or the failure does not propagate to the rest of the building. That's why in this project we plan to design a fuse system. Why it's fused? Because it's not always breaking. For a certain scenario, it will provide continuity. For example, if you have small disturbance, it will provide continuity. When you have earthquake loads or, let's say, wind loading, you have continuity. But then under extreme scenario, the fuse will break. Basically, it's like the electric fuse that you have in your house, to protect the electrical appliance. When overload happens, it breaks. And it's the same. It has the same function. Basically, when a large initial, let's say, disturbance occurs, the fuse will break, and the part that the building, the initial collapse of the building will be, let's say, cut off from the rest of the building.
So it's you permit a certain collapse, but you are limiting it in scope. There is a kind of, not, let's say, sacrificial part, but to save everything, you have to sacrifice something. Yeah.
Yes, exactly. Okay. That's the idea.
No, that's interesting, and as you said, really a radical idea, and I think this is, of course, what gets ERC grants, and perhaps it's also maybe a bit showing about our research topics that there are so few, because we are very close to industry. It's applied research, it's like technical development, and then getting these really groundbreaking ideas is rare, no? But this one sounds really, really, really interesting, right? So, talking about radical ideas, what's your vision about future research? What's coming down the pipe in the next 5-10 years, or what you would like to see being worked on more?
I have, I think, 3, let's say, ideas or let's say specific fields that will grow exponentially, I would say, in the future. The first one will be the sustainability. I mean, sustainability is a very wide topic. People use it sometimes not correctly and so on, but specifically with regard to the environmental sustainability, about how we are aiming, to limit or even go to neutral carbon footprints, to limit the climate change, the increase of temperature. I think this will be first, like one of the main agenda, not only for the research, but also the implementation in the policy and regulation and everything. And in this line of research, I think your current works about, like recycled materials will be, like the next hot topic, I would say. Recycled materials and also digital fabrication, how employing digital fabrication can create more efficient structures with less waste and probably less materials, lighter materials. And also another thing that I found interesting is the circular built environment. I attended several conferences in Switzerland. I think there are some research going on at ETH and also at EPFL, where they try to, let's say, take some components from the building that they will demolish, and then they use it to build some new structures, basically, like the end of a new building becomes the born, like of the start of another building. And I think it will be the, let's say, the next trend in sustainability. That's the first topic. And
can
the second one,
can I just interject? Sorry,
sure.
A follow up. Yeah, this design for reuse and so on. I wanted to ask your opinion about. For me, this is somehow becoming a holy grail. Of what do you think about sustainability limit state in design? Do you think it's something
sustainability
feasible?
limit state?
Yes.
Okay.
Because there is, research people intending to trying to make even partial safety factors for taking this to account. Now in the Congress in Oslo, a group of German universities, the paper was presented by Michael Heist, climate limit state was proposed, and I don't know. I just want your opinion. Like, we design for strength, serviceability, okay, durability probably indirectly, but will we ever end up designing for sustainability?
I would say so. Yeah, there is nothing impossible, and I think having a sustainability limit, it's really a positive way to address climate change issue. And yeah, I'm just thinking, like probably the biggest challenge would be about the implementation for sure, and about the incentive of like whether we all of us needs to fulfill this, because the state of technology and knowledge in developing countries, for example, with developed countries are different, right? And imposing a certain state might be applicable in some countries, but it might not be achievable, or it might not be rational to achieve in other parts of the world. But I think aiming for this would be a positive way to go, to have to conduct life cycle analysis, to limit to a certain extent. I think it's really a positive way to go. Yeah.
Well, of course, this is, let's say, a loaded topic, right? Can we impose the same targets for everybody? Developed countries that already emitted their pollutions, a lot of them in the history, but now you are limiting developing countries and so on. But for me, it was an interesting development to see more and more people like trying to make some proposals for really a calculation, like you calculate the emissions, probably divide them by service life, multiplied by some partial factor to take into account uncertainties of the emissions, and then you baseline that against some, let's say, best practice of current today, and then see how you are fulfilling some targets. But in any case, sorry, I interrupted. You were talking about, let's say, future research lines. So this was one that was sustainability, recycle, reuse. Yes, please.
Yes, thank you, Nico. No worries. I think it's a very interesting and nice discussion about that. And then my second, let's say, opinions is about the field where civil engineering and also artificial intelligence, machine learning will overlaps in the future. Like nowadays we have seen more and more research in our field employing the helps of the computer science, like how to identify using computer vision, how to identify cracks, to classify cracks, how to monitor structures using AI, and how to do a monitoring and so on. I think in the future this will be another topic. I think like even in the curriculum, I would say in the next 5 or 10 years, there will be a lot of overlap, between probably computer science and also civil engineering degree. At least we need to equip our new generations with the ability to, to understand how the science works, how the machine learning works, like not to use black box, but to understand really how it works and so on. Yeah, we are a bit behind than other sectors, like comparing to manufacturing or logistics or transport. People are already developing self-driving car and self-assembling robot in manufacturing. But I think our time in civil engineering has come, and it will be done in the next 10 to 20 years. That's the second opinion about this. And then my third one is how to create, let's say, resilient and also long-lasting infrastructures. It's also a wide topic. You can define resilient in many aspects. You can achieve long-lasting infrastructure in many aspects. Durability, one of them, and then another thing is many interesting part about that. But one thing that I believe will play more important roles in the future is monitoring of structures. Because especially let's say in Europe or in the US, I think the majority of the bridges are now approaching the end of their service life. The bridges that were built in 1950s, 60s, they need to be either demolished or strengthened. At least they need to be assessed first and monitored. And without the help of sophisticated and accurate monitoring and assessment, there will be a huge disadvantage, because the government doesn't have the budget to demolish all the bridge and rebuild it. So we need to be smart and wise to decide which bridge needs to be, let's say, maintained and then prolonged, but which bridge that must be demolished, And I think the monitoring and also the application of, let's say, like a digital twin. Basically, you have monitoring and aided by, let's say, the twin of the bridge that you have in your computer model to identify if there is some disturbances or some defects in your structures. You need to have that in the future.
That's no, I completely agree. Absolutely, this let's say digitalization and increased use of automation. But it's also interesting what you said. In the end, it in a way may be advantage for, if you say that Indonesia is now developing, let's say, very pronounced with the highway network and so on, that you are able already now to include this from the start in your infrastructure, which for the US and Europe would be very costly to include into structures from the 50s, 60s. So definitely, to take advantage of that as best as possible. So I want to switch now to a bit maybe more, let's say, kind of personal aspect, but we covered, let's say, the professional, but maybe I would like to ask you a few things about, let's say, your personal experience of this professional life, right? So you said the research lines for the next 5-10 years. So I'm not going to ask you where you see yourself doing research on these topics, but I do want to ask you, like, how you view this. Basically, is it a necessity? I mean, to advance in your career, for sure, you had to travel to UK, to Switzerland, to now Spain, all the while trying to maintain and keeping successful relations with Indonesia. So that's, spanning the whole globe. How do you view that, as a positive thing or as a burden that is now maybe aided with all these online tools? Because this goes into the kind of sense of identity and rootedness, no, in a community and country. So what's your personal experience, if you can share on this?
I would always see, like mobility as a privilege, not a burden or not a drawback, because some people probably say, I want to stay in one country for my whole life and so on. But for me, actually, being able or having the opportunity to live in different countries, to work there, to do research there, to meet their people, to learn their language and to experience their culture is always a privilege. Why privilege? Because like you have a first-hand experience by being there, by collaborating with the people. Like without the mobility, I will never meet many colleagues and that I have now. Like the network will be probably very small, and then you will see and experience different kind of culture, not just in the research but also in general culture. And also I think it's very important for your self-development. either as a person or as a, as a researcher in the profession, for example. And for me, especially coming from Indonesia, who is currently still developing and moving to many European countries, makes me realize that there are many things to learn, like many things, many innovations that I can get there, but also to think about how to later implement it in my country, to contribute, how to implement the technology and so on. For example, when I was in Switzerland, I attended several workshops and discussed with some professors about digital fabrication. I was always fascinated about digital fabrication, and I think Switzerland is one of the leading nations in this aspect. They have like a national research center for this. And I talked with the professor, and I said to him that it will be tough to bring this to a country like Indonesia. And I'm not saying this just because of, to discredit or to create a negativity of this technology, but I'm just thinking that it doesn't work like that, because we compare the labor work price, basically, like the cost. In Switzerland, like if you hire one mason, probably it costs you like 150 euro per hour, right? And then in Indonesia, you pay 1 hour, or even 2 euro, I think 3 euro per day. Per day. So it's like 100 times cheaper. And if you want to substitute all of the workers with robots, you will create another social issue in this aspect, right? So it's very interesting, like not to see research just from the pure view of research, but also how it can be applied in different parts of the world. And I'm not saying that digital fabrication is not going to solve the problem, but if we want to have this to really solve the problem, we need to find a way to be able to apply it in other countries. And why? Because, like Indonesia is actually a country that really needs this kind of innovation, because we are the one who is currently building a lot of structures, right? Not in Europe. I mean, you have some new projects going on, probably like 1 or 2 mega infrastructures in a year or 5 years, but this technology is really required, like by countries like Indonesia, probably India, Malaysia, or Philippines, a lot of countries in Southeast Asia, or even in Africa, for example, because we are currently having the infrastructure boom. And, being able to live in 2 different parts of the world, which has very 2 different backgrounds, different practice, I think makes me realize and makes me look the problem with a wider and holistic perspective, I would say. That would be the privilege, Nikola.
Okay. And I know probably that, like, if you were doing an interview in Indonesia, a question would be, you've been to all these countries, like what ways of doing things would you bring to Indonesia? But I want to flip it around and ask actually, what is it as an Indonesian that you think that you brought and that should be perhaps more done in these countries the way it is done in Indonesia? What can and should we learn?
Okay. I would say, let me think a bit. Yeah.
I'm asking because, I mean, since we met, I really liked you, and I think we really had always very nice conversations, that you were always very, very polite, very positive, always very positive, constructive attitude. So I think it's, I cannot say if it's representative of Indonesia, but it's a really positive energy, and I see how you are talking about building the country and so on, that there is a lot of motivation. I don't know if it's shared among all Indonesians, but I see that as a very positive thing, patriotic even, right? That is probably in some places missing, right? I think in this line.
Yeah, the keyword for me would be probably collaborative approach. Like the way we see problems and the way we try to tackle it. I think in a country like Indonesia, because we have very different, let's say, backgrounds, we have different. A bit different perspective and so on. I think it's really the collaborative approach, like if you can deal one aspect, if you can work on one aspect from different perspectives, sometimes you can get more effective solution, because probably you don't think some perspective that you don't have, like you can rely on other people to think about that. And also how to work in a large scale team. I think it's also a big thing in Indonesia because like in a project, for example, we have so many people are involved in that and doing the managerial and how to lead the team. I think in here it's I would say even it's more challenging. I think in here.
Yeah. No, I can imagine. I think it's very, let's say, diverse country, and so really for it to function, it has to be right collaborative and positive mindset. So I think as we are kind of approaching the 1 hour mark for our podcast, and this being the Young Members Group podcast, I do have and want to ask you. You've been involved from very early on in the FIB Young Members Group internationally, where you are now the secretary, but also a lot in the Indonesian Young Members Group. So how do you see this role of the young engineers in the FIB, the ways that they are contributing now, that maybe they can contribute more, or some more help that they need from senior members?
First of all, I think the initiative of FIB to create this young members group is a very nice idea, to say, because sometimes when you are young and you are in a group with more senior people, especially in the countries where there is a clear hierarchy, it's a bit difficult, to be able to speak freely, to present your ideas freely. And being in a group with other young engineers, I think give you some more freedom to give your ideas and to present it. And I really believe that young engineers will be the backbone of the development process in the modern world, not just in our countries like Indonesia, who is still developing, but also in Europe, because like many new innovation, as we discussed before about the future research, it's really in the hand of young generations, to be able to adapt with that, because like the let's say the knowledge, the skills that we obtain during our university study might not be applicable anymore, even for senior members. Like even for senior engineers, they probably will not be able to adapt with the new advancement that happens really fast. So I think it's really our role to take the lead. I mean, to take the initiative to always update ourselves with the new knowledge, with the new skills, to accommodate, let's say, the necessary changes in the construction world. And another thing that I believe is very crucial for FIB is being the bridge, being the bridge between the research and practice, because doing it independently, like just doing research or just doing in practice in a perfect way would not be sufficient without without being working together with the two. So I think because like innovation will never be a really good innovation without being applied. And at the same time, if you are in a practice and then you are in a stagnant situation without any innovation, then you will not develop as well. And FIB is really becoming the missing link. It's becoming the bridge between the gap. And young engineers will also be the bridge, let's say, between research and practice, between the innovation and also the application in practice. So I think we have a lot of responsibilities to do, not a burden, but more as an opportunity and as a privilege. I would use this word a lot, but I think it's a privilege to live in this kind of era where we learn so many different things in a very short time. And I think it's really our role, like our responsibility to handle, to contribute to how this world will become.
No, I agree. Thank you. I think we should be more also thankful. We really live in a technologically fantastic time, and we should be curious and interested in improving it and making the most of it. Yeah. So, Andri, it was a real pleasure, as always, talking to you, and I'm sure that everybody listening will enjoy. Thanks to them for sticking out to the end, and I hope to talk to you again soon.
Okay, thank you very much, Nikola, also for having me here. Thank you.
Thank you.